Hi guys, it's Dr. Jamal again. I have some new information on Remdesivir, which is a drug that targets the SARS-CoV-2 virus, which causes the COVID-19 disease. By now, you're already aware of the fact that this pandemic has led to the death of thousands of people, and there has been a significant economic damage. There is a new study that just came out recently, and they looked at how effective this new drug is, meaning Remdesivir, against the SARS-CoV-2 virus, and I will be presenting some of that data today. So essentially, there is a race against time to slow down the pandemic, and there are some kind of broad goals as far as how to achieve that. Number one, we can reduce the number of deaths. We can also decrease the pressure on the healthcare system. And there is a new study. They describe Remdesivir as a drug that has direct effect on this SARS-CoV-2 virus. It targets the enzyme that is responsible for the replication of the viral genome. This study came out of the University of Alberta from Canada. So in terms of what they found, they kind of describe the history of Remdesivir. Previously, Remdesivir has been studied against Middle East respiratory syndrome and also Ebola, and it has shown some efficacy against those viruses. But now we are kind of using it to target the SARS-CoV-2 virus, which causes the COVID-19 pandemic. And this medication has something that is known as broad-spectrum antiviral activity, meaning it targets a number of RNA-based viruses. Specifically, it targets the RNA-dependent RNA polymerase, which is the enzyme that is responsible for executing the replication machinery, the RNA-dependent RNA polymerase, which helps the virus replicate its genome. In terms of how this drug targets the virus, the picture on the left is ATP, which is in red here. And this is the molecule that the virus uses to build its RNA. And the picture on the right with the green label here is Remdesivir, which looks very similar to the picture on the left. But when the enzyme comes to integrate one of these two, it doesn't know the difference, so it would incorporate this drug into the RNA structure, and the enzyme will continue to replicate itself. In terms of the setup of the study, they purified the active part of the SARS-CoV-2 enzyme, and they looked at what's called enzymatic kinetic. It's just a fancy term in biochemistry, meaning they looked at how efficient the enzyme is at interacting with the new drug, and they find this enzyme is very good at adding the drug to the growing RNA molecule, which is eventually what we want. In terms of how this works at a mechanistic level, there are two key ideas here in terms of how the drug inhibits the replication of the virus. There are two key properties that drive this process. First, the enzyme has to choose Remdesivir over its natural counterpart, the ATP. For example, if you have a group or a club that you want to join, and you have a friend who also wants to join the same club, and the space is limited, meaning the group or the club wants only one person, that club or group has to choose one of you, either you or your friend. And the same holds true here. This enzyme can either incorporate the ATP or the drug. In this case, it chooses the drug over ATP, which is a good thing. Second, there's something called delayed chain termination, which is also a property that helps the enzyme integrate the drug. It's called delayed chain termination. because the enzyme does not stop incorporating the building of the nucleotide right away. Once it integrates the drug, it would make about 3 more nucleotides before it recognizes that this is a futile attempt. It's not something that the enzyme needs to continue. So the whole process is slowed down, and this allows the drug to sneak in and inhibit the replication of the RNA molecule. Here is just a diagram showing how this works. The green circles are the newly formed RNA molecule. The white ones, the white circles here are the old template, and the oval, the blue oval shape here is the enzyme, the RNA-dependent RNA polymerase enzyme. So essentially what happens is the enzyme is going to continue building the molecule kind of this way. And here you have the introduction of the drug Remdesivir, which is red here. It's going to bind to a different nucleotide called uracil, and it's going to continue to build two or three more nucleotides before it stops here. So it's stopping here, and this is the process that is called the delayed chain termination. So we call this process delayed chain termination, which is a good thing because there's a native mechanism that the virus uses to proofread the replication steps. For example, if a virus makes a mistake, it can go back and fix that mistake. But in this case, this delay process allows the drug to integrate into the newly formed RNA molecule. Here is just a table showing the selectivity of the virus or the selectivity of the drug for the virus. Here we have SARS-CoV-2 that's being compared against the Middle Eastern virus and also the old SARS virus. This is the one that caused the pandemic back in 2003, 2002. And here the numbers are on the far right here. So essentially the lower the number, the better it is. The SARS-CoV-2 number is 0.28 and the Middle Eastern one is 0.35. The old SARS virus is 0.32, and if you compare it to Ebola virus, it's 4. So the lower the number, the better. So for the SARS-CoV-2, the number is 0.28, which is a good thing. So essentially, they take the data, the kinetic data for Remdesivir, and then they compare it against the data for ATP, and that's how they come up with these numbers. So just because you have a drug that works in a lab, it doesn't mean you can give it to the patients. And obviously, clinical application is a bit more complicated and it's quite challenging. And clinical application usually go through multiple steps. Research is the first phase usually. That's where you figure out the efficacy and the safety profile of a medication or a drug. And also, you go through what's called different phases of clinical trials. There are different clinical trials, trial number 1, 2, 3. And Remdesivir is already in this phase here, in the clinical trial phase here. And then you move on to the get approval or rejection from the FDA. We have some interesting data recently. This is just the clinical data based on observation that physicians kind of shared with us. This data comes from the University of Chicago, where they took 100 patients and they gave them Remdesivir, and they saw quite an improvement, at least in the majority of the patients. But we still need what's called randomized controlled trial. That's where you have 2 different groups of patients. One group, you give them the medication, and the other group does not get anything. And you compare these 2 groups over time and see how they do. There are a lot of institutions that are doing this type of studies, and we're expecting to see more data soon, and then we will make a definitive conclusion as far as the efficacy of this medication against the SARS-CoV-2 virus. In terms of public health and effective approach to disease control, obviously we are taking a multi-pronged approach here. Developing new drug is just one step. In this case, Remdesivir is a good candidate that is undergoing extensive clinical trial. Another step that we can take is explore existing drug. For example, hydroxychloroquine and some other drugs have kind of shown to have some effect, but the data is not conclusive, and we're doing some studies on this. And ultimately, you want to develop a vaccine, but it's difficult to develop a vaccine. At least it takes a year for a vaccine to go through the trial phase, and to bring it to the clinic, it takes a while. But this is also being explored right now. Ultimately, the key issues remain social or physical distancing, quarantine, testing, and also contact tracing and isolation. These are the key public health measures that we still have to implement and rely on to control this pandemic effectively. For now, basic things like hand washing is also a key to controlling this pandemic. Wearing your masks, and not just wearing them, but wearing them properly, is also a key element of controlling this pandemic. Thank you for watching this video. Subscribe for new content, and leave me some comments. Stay safe until our next video. Thank you.